Hi, this is Paul. Welcome on the second research and development video update. If this is your first time here, please subscribe to my channel right now. Last time I talked about 5 rating methods I will implement into Gene 2.1. They are independent from amount of balls in a drawing machine. Then I briefly touched the 6th rating method based on probability and dependent on amount of balls in a drawing machine. At that time, I didn't know the right formula to use, but after some search I found it and did quite difficult and complex calculations. So today I'm ready to present my progress in further development. For now, I will not use blank sheet of white paper because the formula of probability is really complex and it would take a lot of time to write it down and to make the calculations online. Instead, I will show the picture of the formula and then present its results and outputs. So let's show the formula on the paper. We have it right here. So the probability of event x and y is equal to combinations of drawn numbers from the first drawing machine and based on the amount of balls in the drawing machine and multiplied by combinations of drawn balls, number of drawn balls from the amount of balls in a drawing machine. And this we can write in this form using binomial coefficients like this. So we have a1 on a1 to 0 and a3 on 0 to a1 divided by a2 on a1, it's in brackets, times or multiply. In the same for it is for the second row, and we have different characters or variables where we have b1 to 0, b3 from 0 to b1 and divided by brackets b2 by b1. So that's the formula I found, and it's relevant to calculate every probability of every lottery with 1 or 2 draws, or we can extend it with 3, 4 and more to again multiply it with parameters relevant for the 3rd, 4th or 5th draw. To enlarge it and extend it, we will use basic formula which is relevant for combinations, and this form is actually relevant for permutations, or how many scenarios we can have. And just let me tell you the difference between permutations and combinations. So permutations are ordered. It means that, for example, if you are drawing numbers like 1, 2 and 3, it is different when you draw numbers like 2, 3, 1. So these are two different scenarios. But for combinations like we have in our lottery, is 1, 2, 3 is the same like you draw 2, 3, 1 or 3, 2, 1 or 3, 1, 2. So these scenarios are the same. We have the same drawn numbers. But if you have, for example, 5, 6, 7, it's already different, even the combination. And the formula we write in binomial coefficient is called, so it's in brackets a on b is equal to factorial a of a and divided by factorial b, and in brackets a minus b factorial. This area is permutations, and if we add the b factorial, then it's formula for combinations. And when we apply that formula into this big main formula, then it will be extended to these forms, and this first is equal to this one. So we have first brackets which is relevant to this division, then the second bracket is relevant to that division, and the last is relevant to the last division. So we can look for the last, as we have A2 is below, and just notice there is a not division and it's multiplication, so that's why we inverted the value. So that's why the A2 is below and A1 times A3 is on the top. It's if we look for the formula, then it corresponds together. So we did this one for the first row, and in the same way we will do it for the second row, but with different variables, like we have here. Instead of A, we are using for the second row B1, B3 and B2. We have also indexes I, which is from 1 to A1 plus 1. It means how many variations we can have for the first row, and J is used from 1 to B1 plus 1 is how many variations we can have for the second row. That I will explain on the second side. And then we get the probability value, and to get the how valuable is the probability value, we will invert it and we make it like the value is equal 1 divided by P. The P is the whole formula right here. So this is the formula we are using for our case, and let me show it on one example that you better understand it. For example, we have Powerball, and in our case we are selecting 5 numbers from 69. So in our case the A1 is equal to 5 and A2 is equal to 69. This is the number of balls in drawing machine, and this is how many numbers will be drawn in this drawing machine. And then A3 is just simple A2 minus A1, so 69 minus 5 is 64, so A3 is equal 64. And then the second row has the B1 like we have here, and this is one number is selected from 26. Amount of balls in the drawing machine is B2 like we have here, B1, B1, B2, and B3 is the difference B2 minus B1. It means it's equal to 25. Then we will calculate the number of variation as it is like here. So it's the number of variation is from 0 to A1. It means if you have A1 5, then you have number of variations equal to 6. So you can have 0 hits or 5 hits, the maximum. So you can have 0, 1, 2, 3, 4, 5. And the Y is relevant for the second row, where you can have 0 matches or 1 match. So it's 0 and 1. And from that we can calculate, or we have to calculate, the number of variations, and it's equal where we put the A1 plus 1 like we have here, so, and multiply by B1 plus 1. In case of Powerball, the number of variation is equal A1 is 5 plus 1 is 6 times, and B1 is 1 plus 1 is 2, so 6 times 2 is 12. So we will have 12 combinations that can occur. It means, for example, that you can have 0 and 0 matches in the first and second row, or you can have 3 matches in the first row and 2 matches, sorry, not 2 but 0 matches or 1 match in the second row. So if we look on this matrix or table, the size is equal to the number of variations, and in the vertical line we have variations for draw 1, it's from 0 to A1, and in the horizontal line we have number of variations for second draw from 0 to B1. So in our case it will be 0, 1, and here it will be from 0 to 5, and that table will have 12 cells, and each cell will have different value. So for example, if you have 1 hit in the first draw and 0 hits in the second draw, then we will have this scenario. So it will be equal some value of probability, and this value will be different if you have 0 hits in the first draw and 1 hit in the second draw. So there will be another value for the probability here. These two are not the same cases, and that I will show a little bit later as well. In case to understand the probability has a range from 0 to 1. The 1 is maximum. For example, if you have only one ball in some box with one number and you have to select it, you have one try to select it, you will always select it. There is no any other chance. So the probability to select the ball is equal to 1. It's 100%. But for example, if you want to say I will live on Mars the second day, the probability is equal to 0. There is no chance that you will live there tomorrow. Yeah. So that's the range from 0 to 1. And that's the basic theory I wanted to explain to you. And now I prepared some calculations which I powered by Excel to make it quicker. So as I presented last time, there are the 5 rating methods where I am using different functions for rating, like the square, exponential, factorial, or x on x. And let's see what value we will get finally. So if we put 0 matches, 1 match, 2 matches, 3, 4 matches. I click the button and we can see how much value we are getting. Today we have the scenario that x is the value is equal to x is number of hits we have. So when we have 2 hits, it's equal to 4 hits. We have value only 4. But if we use the square, the 4 hits has value already 16. And using the x on x, it has value 256. And if we compare it with 2 hits, it's much more higher than to have 4 hits than 2 hits using this x on x method, or this one, the x squared has value 4 and this is 4 times higher, but x on x is 4 and it's much more higher here, and in total we are getting, like you see, the higher average mean as well. I can increase it if I change some number of hits to see how it's growing. So let's start it, and now you see when you have 4 hits and using this method x on x, you have still this value. But if you have 8 hits, which is probably the maximum in the lottery I can imagine, because I have never seen lottery where you have to match more numbers than I think 7 or 8. Maybe there is one, but it doesn't matter. But you can see the difference. If you have 6 hits, it's almost 50,000 the value, but with 8 hits you have the value much higher. It's more than 1.5 million the value. And it means if I will have in on one wave 7, 6, 5 hits together like this, and assume I see it will not beat these 8 hits. So this wave only with this will be much more stronger than this one. And these 5 rating methods are not dependent on amount of balls in a drawing machine. So if you have 5 hits and in the drawing machine there are 10 balls or 100 balls, you will get still the same values here. And now I will show how it looks with the probability. So we have drawing machine 1 and drawing machine 2. And what we can do, we can a little bit play with drawing machine 1. So we can select, for example, 3 balls from 10. And then we can calculate the probability. So as I have shown, this size or the matrix of variations, the number of variations, and here you can see it. As there is no second draw, it's always 0, but the number of variation is equal to 4. It's 3 plus 1. So we can have these variations, and every variation has its own probability. And to select no number from no, it's equal to 1. It's always probable. So the second row now here is not influencing at all the probability value. So this is equal to this. Then there is this assume px times py, or I would say p of draw 1 times p of draw 2. So it's equal now as we have only draw 1 now activated. And then I will invert the value we are getting here. It's 1 divided this product of px times py. And you can imagine that it is the probability 1 from 120. So after 120 tries, it's very probable we will match or hit all 3 numbers. So we should play the lottery, for example, 120 times to get these 3 numbers. Or we have to, if to have 5 numbers, it's much more or less. We can play it only 5 or 6 times, and then we get 2 matches. And you can see one interesting thing, that to not to select or not to have 0 hits has higher value, or has higher value, or is more difficult than to hit only 1 number. Now let's see how it will change. I will copy it just below. And now let's see if I increase the amount of balls in drawing machine. So it's recalculated, and you see, if you compare it, you are getting much higher value if you hit 3 numbers when the gene is running. It's more than 4,000 the value, and it's much more than 120. So in other words, you should play the lottery 4,000 times at least to hit these 3 numbers. So it's getting worse, but in our gene is giving the higher value, which is then considered to print the best result. I can also increase it to 60 just to see that, and you see we are again getting much higher values. There is also percentage, which we can compare here as well, and it's just recalculation to percentage. So the maximum value we can reach, we can put it to 100%, and then the rest is calculated. So for example, to hit 2 numbers, it's still less than 1%. You are getting value less than 1% compared with 100%. In this previous case where we had only 10 balls in a drawing machine, you have 2%, 1%, almost 5%, then 100. So you can see it's like exponential growth or something like that. And as you see the differences, if I put here number 3 using these 5 previous methods, none of these methods is actually giving us such high value to hit 3 numbers. So these methods are not so tough like the probability method, and I would like to use them as well, because the advantage of little bit softer method is also that you can get more smooth and more plain wave. This wave you will be with much higher peaks. And now let me show it how it works with 2 draws. So we can start 3 balls with 10 and 1 ball from 5. And now you see the number of variation is much higher. Is equal 3 plus 1 is 4 and 1 plus 1 is 2, so 4 times 2 is 8. So we have here 8 combinations. And as the first draw has, you can have no matches in both draws, or 0 match, 1 match in the first and second draw, and you can continue. So, and the best scenario is 3 matches in the first draw and 1 match in the second draw. Here you can also see the probabilities, and I like to point out and why we have to use such kind of metrics, as there is a difference between 0, 1 or 0, 1 here. Between these 2 cells is difference here, and we can see it here. For example, if you look, we have assume 2 plus 1 is actually 3 matches, and we are getting 28 value is 28. But if we have 3 matches only in the first draw, we have value 150, and it's logical. You can see to hit, let's say, 3 numbers is much more difficult than 2 numbers from 10, so we are getting higher value. You can also see it here. For example, when it is easier to hit 1 number from 5 than no matches, or sorry, I don't know if I'm saying that right, but doesn't matter. You can just compare these 2 cases. So you will have here higher value than to match 1 number from 10 and no matches in the second draw. You can also see that this case has higher value than this case. So 1 plus 1 has higher value than only 2 and 0 here. And let me show now how the probability looks like, for example, with the Powerball. So it's 5 numbers from 69, if I remember that right, and 1 number from 26. And you see we have 5 plus 1 is 6 and 1 plus 1 is 2, so 12 combinations. So there are all 12 combinations we can have, and each combination has different rating. And it's like I said, I see it's exponential, but you can also see that this is more valuable than this one, and for example this one has higher value than this one. So this we should reflect during our calculation. And here you can see also the percentage. So to have all the matches is 100%, but to have 5 matches without 1, it's only 4%. So it is just small part or small value compared with the maximum you can reach, and you can see really how different it is, and the others are less than 1%. So this is also something different, and I'm looking forward to use it and to see how the waves will look like. I'm really curious about that. And let me show at this moment the code inside. So you can see here simple formulas I am using for the 5 rating methods. So we can have here, we have the value is equal to number of hits, or there is the square, so we are just multiplying the hits. Then we have here exponential, factorial, and finally is x on x. So these formulas are short and there is no problem to use them. But when we look for the formulas to use the probability, then we have for the first draw the formula and for the second draw, and this is exactly what we have here. This is the first draw and the second draw, and now you can see how it's written in the code. So the formula is really very long, complex. There are some partitions, factorials, and other operations, and then we multiply these probabilities together, like C3 C1 times C2, and then it's inverted and rounded by 2, that not to have such value. But here I have one big problem, and this is, I don't know at this moment how to keep the generation fast, because if you imagine the speed we have, let me open the calculator. So we have in average 15,000 cycles per second, and if we have, for example, we have to draw 6 numbers for one drawing day second, so these we can divide it by 6, and it means that every second we should use this formula 2,500 times, and it's incredible high amount, and this will slow our generation. So at this moment I really don't know how to figure it out, and it will be a big challenge for me right now to solve it. And if you have some idea, please contact me or write me an email, and then I'll be really glad, because as you have seen what the probability is doing and how much value it is giving to us, it is very good to use it, and I don't want to get it out actually. So for me it means if I want to have I never had, then I should do something I never did actually. And so that's what I am looking forward now, and I will work on it. And also I think there is a last thing I wanted to point out, and I think I'll be able to mention it. And it's also important to realize, or 2 things to mention it to you. And you can see here that why the lottery companies are using at least 2 draws, because when you multiply these probabilities, the complete probability is lower than single probability like this one. And I can present it just here. If I delete this and just keep in mind what values we have here, I will delete it, or I can, because we will get 6 combinations, so I will copy it to here, and you see we are getting, if we want to draw just using one draw to draw 5 numbers from 69, so we have 5 numbers here, and it's equal to this scenario. So you see here we are getting actually lower values here. It's easier to guess just these 5 numbers from 69 than to guess 5 numbers and 1 number from the second draw. But to guess 5 numbers here, it's almost equal and it makes sense together. There is a small difference, but it makes sense because there is also influence if you will not hit zero any number, let's say. Yeah, so that's what I wanted to point out. And last thing, I will probably spread this calculation to you and make it available as a download. Maybe I will a little bit correct it that it can help you if you want to check the lottery you are playing and you want to decide which lottery is better for you to play. So then there will be available download where you can put the values for your lottery, and you can see how difficult it is to match the numbers or to hit the numbers, and then you can decide if you will play, for example, Powerball or Mega Millions. Then all is up to you, and it's recommended actually to play the lottery, which is giving here not such high value like with, for example, Powerball we have here. So as I said, it's up to you to select your best lottery and also play the lottery you like. So that's all for today. Thank you for watching and your support, as it's very important for me. Provide your feedback, comments, and I'll be glad for every like I will get from you. If you missed something, just replay it, and if you are new here, please subscribe to my channel right now. Follow the links in the description, join us on the Facebook page, groups, and see you next time on the third video update. In the meantime, I can release some live stream and some video tutorials that can be simple. So there is a lot of stuff coming, and that's why stay tuned and have a good time.